Top 5 Most Amazing Elements. Number 5. Lutetium. In 1907, Georges Urbain was credited with the discovery of the element and won the right to name them, although chemists later changed the spelling of lutetium to lutetium. Today, lutetium is primarily obtained through an ion exchange process from monazite sand, a material rich in rare earth elements. Lutetium is one of the most difficult elements to prepare, and has no large-scale practical uses, although some of its radioactive isotopes can be used as a catalyst in the cracking of petroleum products, and a catalyst in some hydrogenation and polymerization processes. Lutetium-176 has been used to date the age of meteorites. Lutetium aluminum garnet has been proposed for use as a lens material in higher refractive lithography. Number 4. Chlorine. We all know never to mix chlorine with ammonia, right? Well, besides that potentially devastating fact, chlorine is widely used in making many everyday products. It is used for producing safe drinking water the world over. Even the smallest water supplies are now usually chlorinated. It is also extensively used in the production of paper products, dyes, textiles, petroleum products, medicines, antiseptics, insecticides, food, solvents, paints, plastics, and many other consumer products. Most of the chlorine produced is used in the manufacture of chlorinated compounds for sanitation, pulp bleaching, disinfectants, and textile processing. Further use is in the manufacture of chlorates, chloroform, carbon tetrachloride, and in the extraction of bromine. Organic chemistry demands much from chlorine, both as an oxidizing agent and in substitution, since it often brings many desired properties in an organic compound when substituted for hydrogen, as in one form of synthetic rubber. Number 3. Aluminum. Remember the boom of aluminum siding back in the day? Well, this stuff has 1001 uses, from soda cans to kitchen utensils, outside building decoration, and in thousands of industrial applications where a strong, light, easily constructed material is needed. Although its electrical conductivity is only about 60% that of copper, it is used in electrical transmission lines because of its light weight. Pure aluminum is soft and lacks strength, but alloyed with small amounts of copper, magnesium, silicon, manganese or other elements impart a variety of useful properties. These alloys are of vital importance in the construction of modern aircraft and rockets. Aluminum, evaporated in a vacuum, forms a highly reflective coating for both visible light and radiant heat. These coatings soon form a thin layer of the protective oxide and do not deteriorate as do silver coatings. They are used to coat telescope mirrors and to make decorative paper, packages, and toys. Number 2. Zirconium. It is used extensively by the chemical industry where corrosive agents are employed. Zirconium is used in vacuum tubes, as an alloying agent in steel, in surgical appliances, photo flash bulbs, explosive primers, rayon spinnerets, lamp filaments, etc. It is used in poison ivy lotions in the form of the carbonate as it combines with ruschiol. With niobium, zirconium is superconductive at low temperatures and is used to make superconductive magnets, which offer hope of direct large-scale generation of electric power. Zirconium oxide, zircon, has a high index of refraction and is used as a gem material. The impure oxide, zirconia, is used for laboratory crucibles that can withstand heat shock, for linings of metallurgical furnaces, and by the glass and ceramic industries as a refractory material. Its use as a refractory material accounts for a large share of all zirconium consumed. Number 1. Elements 112–118. Relatively new to the periodic table, they weren't even heard of when I was in high school. Elements 112–118. They are completely man-made by bombarding specific atoms of one element with specific atoms of another, thereby separating each into an entirely new element, only stable, though not necessarily visible, for a fraction of a second. Nunbium was first created on February 9, 1996 in a lab in Germany. This element was created by fusing a zinc-70 nucleus with a lead-208 nucleus by accelerating zinc nuclei into a lead target in a heavy ion accelerator. The two nunbium nuclei so produced had a mass number of 27. On February 1, 2004, the discovery of nuntrium and nunpentium were reported by a team composed of Russian scientists and an American scientist at the Lawrence Livermore National Academy. Most of the others were created or discovered much in the same fashion in different parts of the world since then. As of yet, since none of these have been witnessed for more than a second, their inclusion remains suspect and under investigation.